Okay, Shabab. You see my screen?
يوسف يا دكتور.
Yes.
Alright. So, Shabab, Bismillah ar-Rahman ar-Rahim. So last time, Shabab, we talked about the first law of thermodynamics for closed systems. So this was in the previous lectures, maybe 6 or 7 lectures. We talked about how we can evaluate work and heat for closed systems. We looked at different systems. We looked at piston cylinder, maybe rigid tank, maybe other system for different processes, isothermal, maybe isobaric, maybe adiabatic process. And for these systems and these processes, we saw how we can evaluate the work. We looked at the expansion or compression work. We looked at maybe different, let's say, substances, maybe like if you could have an ideal gas or compressibility chart. You could use a compressibility chart to evaluate properties and eventually evaluate work. If we have, for example, expansion and compression work with a polytropic process, we saw how we can evaluate that for a polytropic process. So we looked at different, basically, methods to evaluate work and heat. Also in the last lecture, Shabab, hopefully you saw the recorded lecture. I recorded a lecture last night or 2 nights ago. And I also presented an example with the electrical work. Okay, so if we have electrical work, how we can use that to evaluate to evaluate certain objectives or achieve certain objectives. Today, Shabab, we'll talk about the first law of thermodynamics, but this time we're going to talk about control volume. And you know, control volume is basically an open system where the mass crosses the system's boundary. Okay, so for an open system or for a control volume, the mass within the control volume or within the system might be changing. For the closed system, we know that the mass was fixed, so the mass is not changing inside the system, or the mass of the system is fixed. Here, for a control volume, the mass of the system might be changing, might be fixed. So depending on what exactly? Depending on how much mass is crossing the boundary in and out of the system. Okay, so that's why, Shabab, for an open system, as you can see here in this diagram, like this simple diagram, you have an inlet and you have an outlet. Let's say you have a 3 kilograms entering the system and you have 1 kilogram of mass leaving the system. Where did the 2 kilograms left or remained? So you have 2 kilograms remained, okay, or went to change the mass of the system. So it went to change the mass of the system. In this way, Shabab, since I have an inlet mass and exit mass and a mass changing in the system, there is the requirement for what, Shabab? For similar to the energy, where we have conservation of energy, here we have conservation also, and in addition to conservation of energy, which we will talk about for a control volume, we have conservation of mass. Okay, so we have conservation of mass. So the mass is also conserved for, in this case. So it's not only energy conservation or energy balance, we have also mass balance. So we can write it, as I mentioned here, based on this example, we can write as the mass, and in general, in a control volume, Shabab, or if we have a flow, we usually like to talk about in terms of unit time. So how much mass flowing per unit time, or let's say here I have 3 kilograms per second. So each second has, let's say, 3 kilograms of mass flowing through this inlet, for example. Usually we call this parameter, this parameter mass flow rate. Okay, so we call this mass flow rate, or how much mass is flowing per unit time. So the mass balance in this case, in the rate form, I call it mass rate balance. And if you look at this mass rate balance, so it's exactly what I mentioned. The rate of mass flowing into the system minus the rate of mass flowing out of the system is equal to the rate of mass change within the system. Okay, so this is basically our mass rate balance. Any question about the mass balance or the mass rate balance?
Doctor,
Yes,
what does CV means?
control volume. So
Okay.
for an open system, an open system, I call it a control volume because let's say I want to control this volume, like maybe a pump or something. I want to see how much pressure inside the pump changing, but there is mass crossing this pump in and out, right? So that's why I call it, I control the volume, not the mass. So for an open system, we call it a control volume. So MCV is the mass of the control volume, which means the mass of the system. Any other question? Any other question?
دكتور،
Yeah.
الحين الماس فلوريت كل هذول الفاكتورز هذول كلهم ماس فلوريت صح ولا بس الايكوال؟
كيف يعني بس الايكوال؟
يعني الماس ان وماس اوت وايكوال دي ام سي في على دي تي، هذول كلهم ماس فلوريت.
لا، الماس فلوريت بس هذه وهذه. هذه وش قلت؟ rate of mass change within the control volume. في فرق.
اوكي اوكي.
So when I talk about mass flow rate is how much mass flowing either into the system or out of the system. Okay. So both they have the same units, لكن each one is different process or different physical phenomenon. Here I have mass changing. خلينا نقول انت تعبي مويه صح؟ تصب مويه في كاسة. إذا أخذت الكاسة حقتك الكنترول فوليوم، الفوليوم الماس حق الكاسة قاعد يتغير حق الووتر مثلا. فthis is the mass change within the system. لكن الفلو اللي قاعد ينزل من فوق لتحت يعبي الكاسة، the inlet, that's the flow rate. There's flow going. Got it? So,
يس.
all right. Any other question? So this example talks about single inlet and single outlet. So what if I have multiple inlets and multiple outlets? Okay, the mass rate balance simply becomes, you can just get the summation of all mass inlets minus summation of all mass outlets. Okay, so the rate of the change of the mass within the control volume equals the summation of all mass flow rates into the system or the control volume minus summation of all mass flow rates exiting the control volume. Okay, and this becomes basically, this is the general equation for the conservation of mass or the mass rate balance, in other words. All right, clear? All good?
Yes.
اوكي. طيب السؤال الحين يا شباب، sometimes يعني sometimes I don't have all the information to يعني sometimes I don't know what's the mass flow rate. Okay, let's say inletting the system or exiting the system. Is there a way to evaluate this mass flow rate? So basically, can I derive an equation that represents this mass flow rate? Okay, so one of the basic equations that we will derive is the following. We'll talk about it, but the important thing is I would like to evaluate this mass flow rate. Okay, that's my objective now. So how can I evaluate this mass flow rate? So in order to do that, let me talk about one thing. So assume I have a fluid flow. Okay, so some fluid. It has a certain velocity, let's call it v. Okay, so this v, so v here is velocity. Okay, let's assume this fluid flow is passing through some area. Let's say this is my area A. Okay, So basically this fluid is perpendicular or normal to this cross-sectional area. I have some area, space, planar area, A, okay? And it's moving from one point, let's say it's from this point to this point here, which is crossing. Let's write it. Let's take a small area from this fluid, okay, to this point here, and this is the small area. Start the fluid here until it reaches this area. So if you look at this cross sections, now if you look at this fluid, so this fluid starting from this location, if you take the volume sweep, you can draw this cylinder يا شباب that represents the volume sweep by the flow. And the flow moving from this point to this point, it has this volume, okay, of the cylinder. And as I said, I took here only a small area of this fluid. Let's call it dA. Let's call this dA. All right. So again, the fluid moved from point 1 to point 2. Let's say at point 1 it was at T1. At point 2 it was at T2, which is time. So the time it took to cross from 1 to 2 is basically what? Tt, which is T2 minus T1. Okay? And the distance traveled by this flow is simply what here? This distance, I'll call it S. All right? So S here is simply distance. Here, T is basically time. So if I want to draw or write an equation for this volume, ya shabab, which was swept by this flow, so let's call it a volume, equals, what can I write an equation for this volume? What would be the equation? Huh? شو رايكم؟ السؤال واضح يا شباب ولا في شيء مو واضح؟ الايديا واضحة هنا. أنا عندي fluid moving from point 1 to point 2. I took a small area of this fluid, we'll call it dA, and I followed it. I was following with it. It goes through this velocity, ماشي معاه ماشي معاه ماشي معاه, then crosses this area. So this volume swept by this flow from this point to this point is what? شباب, this is a cylinder يعني. What would be the volume?
DAS
بس بكل بساطة يعني ما أدري.
مساحة في الارتفاع.
أيوه cylinder يعني. Okay. So
أنا حسبتك يا دكتور تقصد يعني وهي تمشي.
قلت لك مشت from point 1 to point 2. What is the volume swept by this flow? خلاص عندك الجيومتري هذا باختصار. Okay. ف is simply S times this cross sectional area. So can I rewrite the distance in another way in terms of velocity and time? What can I write S? ها شباب. S is simply what?
time over velocity.
B over T.
المسافة تساوي السرعة في الزمن. يعني this is basic physics. Velocity times time times area. So I rewrote this distance traveled by the flow as velocity times the time times the dA. Now, if you divide the volume by the time, if you divide it by time, it's going to be equal to what? It's going to be equal to velocity times this area. If you look at the units for this, ya shabab, volume over time is basically what? This is meter cube per second. We call this, ya shabab, what? We call this volumetric flow rate. يعني ايش؟ يعني how much volume I have of the fluid flowing per unit time. Okay, so this is meter cubed of fluid flowing per unit time. We call this the volumetric flow rate. All right. طيب, can I change the volumetric flow rate to mass flow rate now? What can I do to change the volumetric flow rate to mass flow rate?
multiply by density.
يا سلام. الحين عندك الفوليوم, you can change it to density, صح؟ أو change it to mass using density. So density you have mass over volume. فبالتالي I use this equation, so the volume becomes mass over density. So it becomes mass over delta time equals density times velocity times dA. And this becomes now what? This is kilograms per second, which is basically the mass flow rate, which we call m dot. Okay, so now this is يا شباب only for this infinitesimally small area. If I want to calculate the mass flow rate across the whole area, what it would be? For the whole area, it will be what? What we can do mathematically? You know that mathematically. Now if you want to generalize your equation here, so you integrate over the area. You know this يا شباب or you don't know? Calculus. Okay. So this mass flow rate gives me this mass flow rate across this only small area. If I want to find the mass flow rate across the whole area, I simply integrate over all of the area, which I get the final equation for the mass flow rate, which evaluates the mass flow rate as a function of density, velocity, and area. Okay, so this equation applies if let's say the density and velocity is variant at different locations in the area. So at different locations in the area, if you have different density, different velocity, then you need to integrate in this case. في سؤال هنا؟
دكتور
شيء مو واضح؟ Yes.
كيف نسوي انتجريشن للاريا؟
لا تسألني. calculus.
اي بس الاريا ثابت.
الاريا ما له علاقة ثابت. هنا عندك هذه is a function of area. يعني you need to have a equation or you need to have a function for this as a function of area. زي ما قلت لك تو ممكن هنا الفيلوسيتي 2 متر per second في الاريا هذه. في الاريا هذه اللي بجنبها ممكن 3 متر per second. So you have different variation of velocity, let's say with area. Okay, that's why you integrate with respect to area here. So you need to go you need to go back to calculus to see how can I integrate over a planar. Okay, a planar like area, for example. All right. So don't worry about it. We will not go into that in this course here. So relax and don't worry. We will not be going into such thing here. But this is the original concept. You need to understand the original concept that the mass flow rate is the integral over area of rho v dA. Or I can rewrite it as velocity over specific volume. ليش؟ لأنه density is simply 1 over specific volume dA. Okay, and this is basically what I have here. So this is it. This is integrating over area gives you eventually this equation. Remember, the V here is velocity in this case, okay? Don't confuse, it's not volume. V here is velocity. So that's why I try to make it clear. أي سؤال؟ وضحت الفكرة؟ So what did we do so?
دكتور
Yes, go ahead.
معليش بس على هذه النقطة اللي قبل شوي، يعني هذه ممكن بس تستخدم إذا صار البايب يختلف في الأريا.
ممكن البايب، نعم ممكن البايب يختلف في الاريا. لا، مو البايب يختلف في الاريا. الحين انا ممكن عندي بايب زي كذا، اوكي، لكن الفيلوسيتي هنا نفسها هنا نفسها هنا، فهمت؟ فهذه ما اختلفت، يعني الفيلوسيتي is the same everywhere, so you don't need to integrate. I will talk about this actually later, it's coming in 1 minute or 2 minutes. لكن الفكرة انه الفيلوسيتي ممكن تختلف في نفس الاريا نفسها، يعني هذه الاريا هنا الفيلوسيتي تختلف عن هنا، تختلف عن هنا. هذا الانتجريشن، هذا الديفرنس اللي نتكلم عنه، فهمت؟ Let me, if you wait just a few minutes, I will talk about the assumptions we have. Hopefully this will make it more clear. بس كنت بقول انه so far we talked about the mass rate balance, which is the conservation of mass, and then we derived an equation to evaluate the mass flow rate, okay, which is integral of velocity over specific volume times the area. طبعا there are different approximations to simplify, or different forms of the mass rate balance. We use it to simplify our problems, okay? So these approximations are as following. So the first approximation I have, which is what Walid was asking about, for this approximation, I can assume one-dimensional flow. When I assume one-dimensional flow, what am I doing? I basically say, let's say if I have a flow in a pipe like this, okay, maybe the pipe is like this. It has, at each location has different area. However, if I assume my flow is one-dimensional, وش معناته one-dimensional؟ معناته الفlow is perpendicular to the cross-sectional area. Or in this case, I call it boundary. Let's say if I have a system boundary, it's normal to the boundary. So the approximation, the one-dimensional flow is basically the flow is normal or perpendicular to the area, which means in reality maybe the flow like في flow here, في flow down، في ممكن flow actually backward، okay. لكن إذا كان flowing in, let's say the most يعني most of the flow is in one direction, even though I have maybe small flows up and down, I'm gonna assume one-dimensional flow, okay. So I'm gonna assume one-dimensional flow, which makes my flow only in one directional perpendicular to the area. هذا يؤدي لإيش؟ يؤدي إنه also we assume إنه at each area here, at each location, my properties including density and velocity is the same in this location, in this area. So it's the same here, same here, same here, same here, okay? If these velocities or densities are the same across all of the area, the same area across all of this area, then I can simplify my mass flow rate. So the density and velocity becomes uniform or constant with respect to area. So I can simply become rho VA. Okay, so it comes out of the integral, then my area simply becomes A. The integral of dA is simply A. So we get what? Rho VA, or VA divided by small v, which is specific volume. Remember, V here is velocity. وضحت الفكرة؟ وضحت متى يكون عندنا integral we need integration هنا we can simplify and approximate. وليد Is it clear?
ان شاء الله.
ماشي، ما عجبني رد.
يعني مع الامثله يا دكتور ان شاء الله توضح كل شيء.
ما في امثله، هذا كونسبت. الامثله خلاص بطبق الايكويجن هذه بس. يعني in this course mostly we'll work with this. يعني شفتم الكنترول فوليوم we have inlet واوتلت، ما راح استخدم الا هذه الايكويجن. ليش؟ because I'm gonna assume always one dimensional flow في الانلت والاكزit. That's why I'm gonna simplify for m dot equal VA over V. Okay? I'm not gonna talk about integration ولا ذيك. لكن you have to understand the original concept. إنه this simplification is assuming uniform properties with position in the across the area that the flow is going through. Okay?
اوكي.
This concept. طيب، في أي سؤال so far? Any questions? طيب, the second approximation يا شباب is what I call steady state flow. steady state flow. لما نتكلم انه steady state control volume نقصد انه whatever flow is happening. يعني if I have a certain flow, the inlet flow and exit flow does not affect the mass within the control volume, which means the mass does not change within the control volume with time. Okay, so there is no change of the mass. If there is no change with the mass of time, so there is no derivative of the mass of the control volume, so it's equal to 0. If we go back to this example, let's say if I have 3 kilograms entering and 3 kilograms exiting, what is the change of the mass of the control volume? في change or ما zero, ما في change. So the mass will remain the same. عرفتم ليش قلت انه ممكن الماس is fixed, ممكن is changing? So it depends on the mass flow rate of the inlet flowing into the control volume and flowing out of the control volume. If they are equal, then there is no change, or if it's a steady state, okay, there is no change of the mass of the system, which means I can write my energy mass balance here. Okay, I can make this 0, so there is no change of the mass of the control volume, which means my the mass flow rate into the system equals the mass flow rate out of the system. And we'll take an example to clarify this in a minute. Any questions? Okay. So again, here we talked about one-dimensional flow, which m dot equal VA over specific volume, or VA times density. And then the steady state flow is the mass within the control volume does not change with time, which makes the mCV over dt equal to 0. There are important notes يا شباب to realize. It's important. The first one يا شباب is the one-dimensional flow. طبعا أنا أحب دائما أذكر بالشغلات هذه لأنه في طلاب they confuse things together, so I want to make it clear. Okay, one-dimensional flow does not mean steady state. Okay, so don't connect steady state to one-dimensional flow. You could have one-dimensional flow, but it's unsteady. Or you could have steady state flow, but you have two-dimensional, three-dimensional flow. Okay, so one dimension does not mean it's steady state flow. The other important note is for the steady state flow, even though the mass is not changing with time, the other properties, maybe temperature, maybe pressure, maybe specific volume, could be changing with time. Okay? يعني أنا عندي 3 kilograms entering the system, 3 kilograms exiting the system. However, my temperature from time 1 to time 2 is different. So let's say at time 1 is 30 degrees, at time 2 is 100 degrees. Okay? So it could be the properties, temperatures, volume, pressure could be changing. اوكي. واقرب مثال يا شباب انه اذا عندك pump, الووتر pump مثلا, even though it's steady state flow, you could have pressure difference. يعني you are entering the water at one pressure and exiting at different pressure, but the mass flow rate is the same. You could have the same mass flow rate. Okay. So I wanted to clarify these points for you, so that يعني you don't make any confusion. Any questions?
دكتور معلش، ال1 dimensional هو اللي قبل شوي درسناه صح؟ اللي flow rate equal to density velocity area.
ال1 dimensional اللي هو ايش؟ ما هذاك الافكت اوف ذا assumption is one dimensional على الايكويشن حقت الماس فلو، لكن ال1 dimensional وشو؟ لو حسب ما شرحت لك تو.
إنه perpendicular to the area، بس أنا اللي لخبطت هي أي واحدة.
بالضبط. It's a flow perpendicular to the cross sectional area. يعني there is no other direction. وايش غيرها؟ This is the one part of it. The other part
velocity and density are equal.
ما هو velocity. all intensive properties, all of them, all intensive properties are uniform with position in this area, in this cross section area. Okay.
or intensive يعني حتى ال pressure وال temperature
كلها uniform في across the area at that time. فهمت؟
yes.
okay. زي ما شرحت انه with position is uniform with position within the cross sectional area. Okay. هذا ال one dimensional. Any other questions? طيب, let's take an example to clarify or the use of the mass rate balance and mass flow rate. So I have this equation, I have this example. I have what I call a feed water heater. This feed water heater is simply like a heat exchanger. يعني it gets water from different inlets and it takes and it gets water out from one exit at a specific state. Okay, so if you look at this feed water heater, you see that you have inlet 1, you have inlet 2, and you have exit 3. So I'm going to call 1, 2, and 3. You have 2 inlets and 1 exit. For inlet 1, I have water flowing at 200 degrees and 7 bar and at a mass flow rate of 40 kilograms per second. Okay, so I have this water at this state T1 and P1 and this mass flow rate at inlet 1. At inlet 2, I'm giving you the cross-sectional area of this inlet, which is 25 degrees Celsius, and at a second state of a different state at 40 degrees Celsius and 7 bar. Okay, so this is 40 degrees Celsius and this is 7 bar. These two inlets come together, they mix, and they get out from the exit at a saturated liquid state. Okay, so at exit 3, the state of water is saturated liquid at 7 bar, and I'm also giving you here the volumetric flow rate. Just a quick reminder, let me go back here. If you remember this mass flow rate equation, you have V times A, which based on our derivation here, V times A is basically the volumetric flow rate. Okay, so the mass flow rate is simply volumetric flow rate times basically density or divided by specific volume. Here in this example, I'm giving you at exit 3 this volumetric flow rate of 0.06 meter cubed per second. Okay, so this is my volumetric flow rate at exit 3. The question becomes now, find the mass flow rate at inlet 2 and at the exit, and find the velocity at inlet 2, assuming a steady state operation. So this is running at steady state, and we need the mass flow rate at inlet 2 and at the exit, and the velocity at inlet 2. Okay, so how can we solve this problem يا شباب؟
we equate them بعدين نطلع ال specific volume عشان نطلع ال density للinlet 1 بعدين نسويهم ببعض.
Okay, to explain clearly, don't say equate them. Tell me what's the concept I'm gonna apply. Apply the yes,
conservation of mass.
conservation of mass أو مثلا mass rate balance. Okay, this is كده أنت كده واضح. يعني you have to be clear. Okay, so I apply the mass rate balance or the conservation of mass, which is the rate of mass exchange of the control volume equals summation of LS minus exit. I have M1 and M2 are inlet, so it's M1 M.1 plus M.2 minus M.3. طبعا just I don't know if I mentioned this quickly, the mass flow rate I can call it M dot اللي هو dm by dt is a symbol for it for the mass flow rate is M dot. Okay, so M dot is the same as dm by dt. This is my point. So now I have M dot 1 plus M dot 2 minus M dot 3. Okay, so this is 0, so I can find M dot 2 equals to M dot 3 minus M dot 1. Okay, because they're requiring M dot at inlet 2 and at the exit. So what's missing here and what's given? I have M dot 1 given, right? So this is M dot 1 is given. What's missing? I have this is missing and this is missing. What other way can I find M dot 3 مثلا؟
ايه
كيف؟
الساتوريت ليكويد سبيسيفيك فوليوم في اف ف في اي على القياس
ممتاز.
ودي بالماس 3.
So basically you divide the volumetric flow rate by the specific volume at exit 3. Okay? Because I know that the mass flow rate is VA over specific volume, right? So we apply this at state 3, exit 3, and I give you the volumetric flow rate at exit 3, so you don't need to find velocity, you don't need to find area, I already gave you the volumetric flow rate. Okay, so what you need only is to find the specific volume at this saturated liquid at 7 bar. So you go to the tables, you go to 7 bar for water and saturated liquid state, which is the F state, then you find V3 as VF at 7 bar, which is 0.001108. Okay, you plug this here, you put it here, and then simply you get M.3, which is 0.06 meter cube per second divided by 0.001108, which is meter cube per kilogram, then meter cube cancel with meter cube, kilograms goes up, and then it becomes kilogram per second. So we notice that M.3 is simply 54.15 kilograms per second. طيب, now M.2 خلاص, and I found M.3, so this is now given. Now simply take the difference from the mass balance, you get M.2. Then this is steady state operation. You find M.2 as 14.15 kilograms per second. How can I find velocity at inlet 2? So I need the velocity at inlet 2.
We put the equation of conservation of mass. We can solve it by the equation.
الحين الكونزرفيشن ما استخدمتها. الحين ابغى الفيلوسيتي at inlet 2. ابغى هذا الفيلوسيتي هنا. This inlet. what can I do?
ايه يعني عندنا M1 وعندنا M3
عندك
فباقي لنا بس M2.
M.2 M.3 وش استفيد منها في الفيلوسيتي 2؟
ال M2 نقدر نخليها V multiply by density، ودنسيتي نعرفها فباقي بس ال V.
خلك واضح، عطني الايكويشن اللي بستخدمها.
الله تقدر عايز
V raw equal لل M3 minus M1.
يا اخي الموضوع بسيط، انت عقدتها مره. وفي احد ثاني كان بيقول شيء. يس، مين اللي كان بيتكلم؟
بغيت اقول بس نسيت، ما جمعت الافكار، نسيت
ما اسمع. ايش؟
والله. اكيد بقول شيء بس ما نسيته، مو بكامل يعني.
انا ما راح امشي لين واحد يجاوب.
طب
بسط السؤال دكتور.
الفيلوسيتي at L2.
دكتورة ما فاهم الحين، احنا طلعنا M3 صح؟ M.3 و M.1
طيب
فما بقى معنا ال M.2.
طلعنا M.2. طيب برضه هذه M.2 طلعناه. الحين انا ابغى فيلوسيتي 2.
دكتور is it
معلش سبيسيفيك
ايوه
الفوليوم، معلش الفيلوسيتي على سبيسيفيك فوليوم ايكوال M2. ننقل هذا هنا وهذا هنا.
في احد ثاني كان بيقول شيء ولا انا غلطان؟
yes دكتور M2 multiplied by the specific volume over the area.
عيد
M2 rate multiplied by the specific volume over the area.
بالضبط، بكل بساطه يعني. عندك الايكويشن حقت الماس فلو ريت VA over specific volume، خلاص rearrange to find the velocity. يعني ما ادري وش كان الموضوع. يعني you already know the mass flow rate and you need the velocity. شباب هذه without any thinking، إذا عندك velocity، إذا عندك mass flow rate you can immediately find velocity from area and specific volume or area and density. بعدين لو تلاحظون هنا أنا أعطيتك الاريا وجيت هنا وقلت لك اوكي how can I find V2، أبغاك تشوف الاريا هنا، عندي اريا. اوكي، فبكل بساطة انه M.2 equal V2A2 over specific volume 2، فالvelocity 2 equal M.2 V2 over A2. خربتكم الفريشمان يا شباب والاوريا.
لا والله يا دكتور انا قلت هذه المعادله نفسها،
بس ما قلت الاريا، انت قاعد تقول V
صح.
over ما قاعد جبت الاريا.
بس انا دكتور انا ماني فاهم ليش ما استخدمنا طب الاريا فوق مع الام 3.
نرجع هنا، انت قل لي ليش ما استخدمناه.
عشان هي جاهزه يعني مع الفوليومتريك.
ايه اعطيك الفوليومتريك، ما اعطيتك فيلوسيتي ولا اعطيتك اريا، اعطيتك المالتيبليكيشن اوريدي، وحتى فور
اوكي.
المالتيبليكيشن اعطيتك مضروبه كذا في بعض. اوكي، ف you work with what's given يعني في الاخير. That's it. طيب كيف تطلع V2 specific volume at state 2؟ تروح عندك temperature، عندك T2 عندك P2، تطلع تجي تشوف تحصلها compressed liquid and you can approximate for compressed liquid using the saturated liquid data. So as V2 is simply can be approximated as Vf at 40 degrees Celsius, which is 0.01008. Okay. خلاص, you put everything in the equation and you find the velocity at inlet 2. Here we have 25 centimeters squared. In order to convert, the centimeter is simply centi is 10 to minus 2. Since it is squared, you need to also multiply by 2. So it's 10 to minus 4. Okay, so this is conversion. Be careful about this. Then you simply find velocity as 5 meters per second. صعبة دي يا شباب? Is it difficult?
لا واضح.
It's very يعني using the same concept, same equation in a simple way. Yes.
دكتور
تسلم.
من قاعد سالم الآن أقدر أختار أنا أي طريقة بإني آخذ البروبرتيز، سواء كان إذا كان غاز أو إذا كان سائل،
بالضبط.
أقدر أخذها من التيبل أو من الشارت، صح؟ لي الخيار.
على حسب السبستنس المعطى، على حسب الستيت. يعني لو تلاحظون هنا استخدمنا التيبل. ممكن يجيك سؤال في غاز تروح تستخدم مثلا، ممكن يقول لك ايديال غاز، ممكن يقول لك بوليتروبيك مثلا لا اترك البوليتروبيك، بس ممكن يقول لك compressibility ان this real gas. عرفت؟ ف exactly يعني this is always we use chapter 3 اللي هو ال evaluating part. This is how you
بس دكتور إذا قال لي دكتور ستيم، أقدر أستخدم الشارت أو التيبل كيف يعني، صح؟
Table is more accurate. إذا قال لك steam this is superheated water if you can use the table. إذا ما حدد لك شيء معين يعني. Yeah table يعني أنت دائما do it the simplest way. إذا عندك substance عندك له table، ليش تروح تستخدم chart وعندك table يعني جاهز على طول. You evaluate the situation. Any other questions? As I said يا شباب, inshallah next Thursday we'll have a practice quiz for you. It's a quiz to practice for the midterm. And I will give you inshallah detailed instructions on the midterm exam. Okay? بإذن الله. وموفقين يا شباب بالتوفيق.
يعطيك العافية.
الله يعافيك.
يعطيك العافية دكتور.
الله يعافيك.
يعطيك العافية دكتور بس
تفضل.
تحضير.
خلاص I took it.
I'm from another section.
أنت شو اسمك؟
بدر.
بدر إيه. Okay I got you.
يعطيك العافية.